presentation, there's still people coming in, presentation is about IPMI and QEMU. And I started, I'm the IPMI maintainer for the Linux kernel, and I started this and I also have in the background of this, I also maintain a userland library for IPMI that is fairly extensive, and it's fairly complicated. And so I originally developed software there to emulate a BMC so I could test stuff out without actually having to have a real BMC. I could run automated tests. People send me bad stuff. I can simulate it, reproduce the bad stuff, and then handle it properly or tell them how to fix their incorrect implementations. And that eventually grew and grew and grew and grew, and people actually took that, and it's actually been used to make a real IPMI BMC. And in the meantime, my people are sending me hardware reports about bad hardware in IPMI implementations, and having to go back and forth, does this fix the problem? No, does this fix the problem? Was a painful process, and that's when I put the implementation into QEMU so I can emulate things, emulate bad hardware, and make that cycle a lot faster. But first of all, what's IPMI? How many people have used IPMI here? I guess almost everybody. But if you haven't, so I'll talk about what it is. So an IPMI is a platform management interface, and it's designed to allow you to remotely control hardware without having to actually have something running on the system to be able to work on it. So you have a microcontroller that's always running on the system, and you can communicate with that over the network. So there's generally an extra plug on the back of these systems. You plug it in, and it talks to the IPMI controller and not to the main system hardware. So that little microcontroller on there, they're actually not so little anymore sometimes, but it has a communication interface to the host processor to talk to the host processor, and the protocols or what runs over those are the same commands. So you can issue commands from the host processor or from the network and do the same things. But that little microcontroller there has on it hookups to sensors, so measuring voltage, current, temperature, things like that. That has fru data, so you can get to like EEPROM fru data, and then fru data about the actual system itself. And then on the BMC, generally you have something called SDRs, and these describe all these sensors, the fru data, and everything, so it's self-discovery. That's where the intelligent comes in from IPMI. So you can look through these things, you can find out what management controllers are in the system, what fru data is available, what sensors are available, how do I read them, how do I convert them to human readable values, a whole slew of things. There's also an event log, the SEL, which holds events that have happened. Sensors go out of range, system reboots, watchdog timer goes off, things like that. There's internal fru data that talks about the BMC itself. And there's a power supply hookup, or it's more than likely not hooked to the power supply, it's hooked to the local power control on the board, but to be able to turn the power on and off. So that's, in a nutshell, about IPMI. Any questions about this before I go on? About what IPMI is? Okay. So, I implemented IPMI inside of QEMU, and there's two basic implementations that you've got. You have an internal BMC, and that BMC is very basic. All it can basically do is do a watchdog timer and support the very basic IPMI commands. And then there's an external interface where you can hook to the big simulator that I wrote, or anything else you'd like to write, and it supports a fairly complete BMC implementation. So you can create sensors, you can have fru data, you can do all the kinds of things like that you can do in an IPMI system. So you have the basic interface works like this. You have QEMU, well, actually the whole right side is QEMU. You've got the simulator. It hooks through CharDev to an internal BMC front end. Then it hooks over the physical interfaces to the local host processor, and then it has some things that it talks to QEMU to do resets and shuts downs and MIs and things like that. And then in the internal one is similar. It has a very basic watchdog timer, one SDR describes the watchdog timer sensor, and then a little event log. It catches watchdog timer events, and that's all that it does. And then the same basic thing on the right-hand side. So why would you want to use this? Well, I was a little shocked when I started this. I put it out there primarily because I didn't want to maintain it, and I'd like to eventually get it in QEMU just for my own use. But a lot of people were interested in this. I've had several, 4 or 5 queries about this. People that have actually used this in implementations to be able to do this, to maintain their systems with IPMI. And so why don't you want to do this? There's that one. Is you can use your existing management software basically to maintain a QEMU virtual machine. Another thing you can do with this is you can cause things to happen that you can't really cause happen in the real world. It's real hard to make voltage sensors go out of range in a real physical piece of hardware. It can be done, but I wouldn't recommend it. Only once. Only once. That's right. It allows the IPMI maintainer to reproduce bad hardware. I've done this 4 or 5 times this year. I did it on the way here on the plane. I did it. And then there's a lot of software that people have that might expect IPMI to be there just to make it feel better or something like that. And it might fool a piece of software running in a virtual machine saying, well, I have IPMI, I'm happy. And then you might watch, you might want a standard watchdog timer interface. That's probably not a big deal, but thought I'd mention it. So how does it work? It's actually fairly simple. So you create a BMC, and then you hook an interface to it. So there's the 2 different types of BMCs. There's a simulator, and then there's the hookup to the external emulator, and that goes over a CharDev. And we added the reconnect thing, and I'll show that later. But if your BMC fails, your external BMC fails, you just start it back up, and it'll reconnect, and everything's happy. And then you attach that to an interface. It's a pretty standard ISA device. You can have interrupts. You can set the port you want it to be on and things like that. All this is reported through SMBIOS and ACPI. Well, it's coming. But that eventually it'll all be reported through that, so it all works automatically. You can see that. You'll see that in a demo that I have. Actually, I'll skip the demos for now and then come back. So what's left? Well, there's obviously upstreaming the code. I spent a week hiking in the mountains in Colorado, and then I spent 2 weeks in India. Then we're doing audit right now, so I haven't had a lot of time in the past month and a half or 2 to work on it. But when the audit's over, I'll have some time left. I'll be able to get back to it. There's 3 basic interface. Well, there's really 4 basic interfaces in IPMI to hook to the host processor. There's the most popular is called KCS, and KCS stands for Keyboard Style Controller. It actually looks like a keyboard. I don't know why, but that's the most common interface. You'll see block transfer, which allows you to do full block transfers. It's a lot faster than KCS, a byte at a time. There's an old one called SMIC, which is a byte at a time, and you only see on really old HP systems. And then there's SSIF, which is IPMI over SMBus, or I2C. And that I have code that works that does that, but it's got a lot of things it touches. Well, first of all, the PMSMBus code is completely broken in QEMU right now. But there's a lot of other things that have to be done to make it work, like SMBus alerts and things like that. And these are where you can get it now. The 2 basic places. The QEMU changes are on GitHub. For historical reasons, the OpenIPMI project is on SourceForge. And I just didn't want to move it. Issues. If you notice, there's a charge up connection between the BMC and QEMU. And obviously, if you're not careful about that, or maybe even if you are careful about that, that's a security hole. You might be able to hijack that somehow and do bad things to your QEMU implementation, or fool the IPMI stuff into thinking something's actually out there which is not. There's probably other security problems here. IPMI is not known for its great security. There is security in there. There is encryption, authentication, and things like that. Standard stuff you see in security, it's not the best in the world, but it is there. Generally, people run their control networks completely separately from their data networks to help alleviate a lot of those problems. But IPMI is very common in the data, in the IT realm, and in telecom realm. The other big problem is if you're going to take, say, your board or your system and create an IPMI simulation of it, that's a huge amount of work. It requires extensive knowledge of the insides of IPMI, how it all works. And there are unfortunately, or fortunately, I don't know, not many people in the world that know that kind of stuff. I know 5 or 6 people that could do something like this. And I know more than most, probably. The good news is 95% of the people in the world use IPMI for power management and reset. And that's a fairly simple problem to solve. There's actually a guy who did this with the older implementation that I had out there, and he posted it out. This is how I did this, and this is how it made my software happy. So you can go look at that, and he's got a big, long description of the whole procedure to how to set it up. It's pretty impressive because the documentation on it right now is pretty scanty. So he did a little bit of work on that, but it made him very happy, so I guess that's good. Okay, any questions so far? Yeah.
Support serial over LAN?
That is a good question. IPMI does support, in the standard, the ability to do a serial port over the LAN through a standard secure interface. And so you have to go through all the authentication and everything like that to get to it. That could be very easily supported. IPMI Simulator right now actually supports serial over LAN, but right now it would only talk to a real serial port. It won't talk over it had to talk over the CharDev to QEMU. And I don't have support for that. It wouldn't be terribly hard to add. I'm not going to do video or anything like that. So there are implementations of video over IPMI. People will do consoles over IPMI. It's not standard, and it doesn't sound like a good idea to me, but a lot of people do it.
How does OpenIPMI communicate stuff out of band? Like, why do the VM is off?
If the VM is off, it uses the network connection. If you look back on the picture here, from IPMI's point of view,
OpenIPMI.
how does it communicate with?
IPMI, I use it at home, so I have a basic idea of how you use it for power management.
Mm-hmm.
But in OpenIPMI, when it starts talking to QEMU, if I send a power on command, how can I hook that command to start the VM?
Oh, okay. We can go into the demos now. Okay. Ooh, this narrow screen doesn't do much for me here. All right. So this is the configuration file from OpenIPMI. And it has things like, setting up the LAN connection, authentication, GUID. But one of the things it has down here, part of it will be very familiar with you, for you, a lot of you guys, that the serial connection right here to a VM and a command to start QEMU.
But it could as well be start.
It can use libvirt or whatever you want to do to start QEMU. I've hacked this in for my own use. And you can have it start when you power this, when it starts up, or you can have it start later. Right now I have it starting later. So, wish the screen wasn't quite so small. So if I start OpenIPMI here, it creates a very basic system. Come down here. Let's see. So I can status, I can see the power's off. I don't have a connection to, there's no VM out there right now. So I can say power on. And rebooting up. So I can log in and do whatever. I can say power off. So it's powering off right now. And it's not off yet. Now it's off. So you can see the normal power management kind of things work. We can power it back on.
Don't need brush anymore.
We can reset it. All the normal things you can do. This is what 95% of the people do over IPMI. I come from the telecom world, and they do data trending on voltages and temperatures and things like that. But that's mostly what I focus on. But this is what most people do. That's it. So the watchdog timers work. So I can go in and say. It's set up. Okay, watchdog timer's loaded. So it's not stopping the watchdog. We wait about 5 seconds. That's what I have the timeout set to. And reboots. And also, you can go over here. Oops. And you can say, and you can see there the watchdog, it actually got a sensor log that said the watchdog timer went off.
Can you also get that on some kind of connection? Someone can watch the system event log by connecting to OpenIPMI?
Oh yeah, you can have OpenIPMI here. I'll have to type the whole command in. Open. Remember all this stuff on the top of my head. Okay, so we're connected here. There's our sensor. Clear it out. So. Of course, it's not going to be there. So the watchdog goes off. And in a second here, you can see the sensor come. And there's the radar record. You can see that, where is it? Well, it was an assertion that the watchdog timer went off. Looks like I have a problem in my SDRs. But yeah, so you can have OpenIPMI connected and do all this kind of stuff. You can do the same power off from here. So you can say control set. Oops, it's not happy. So it's all pretty transparent and works. Anything else anybody wants to see? Oh, there's sensor setting. I can set sensors. So let's see. I have if you look in my emulator, I've got two sensors that are temperature sensors. So I can go into here. I can set my temperature sensor, whatever value I want to. Set it to 130 degrees. Oh, there, something went wrong there. So you get an event saying, is the temperature sensor went high? So this is an internal sensor. You can also have sensors that are external. So I can go over here. This actual sensor, I'll go ahead and set it. there it went off again. I should have put a different value, but it went to 130 degrees there on this, a different sensor. And that sensor is a pole-based sensor. So you can look down here. That sensor actually monitors this file right here. It pulls it every second for data. This is actually used in real, this can be used for real BMCs. So this is actually mostly for monitoring the /sys file system for physical sensors. But you can do it you can simulate whatever you want to with it. And it works with the IPMI tool, OpenIPMI, it all works pretty transparently. I haven't tried free IPMI. I assume it would work too, standard protocol. Yes?
I know this sounds like a security hole, but is there a use case for passing through actual sensor data from the underlying hooks? Yes.
You can. Turn him on. It's all available here, so you can run. So you've got all the stuff available here, same basic interface, through the KCS or BT or whatever. That's the local host interface. So you can. A lot of people do that too. They'll monitor all their stuff locally and pass it upstream. It works either way.
There was also something like lights out call, right? Something like lights out call.
Okay, that's a Dell thing, I think. Yeah.
Yeah, is it similar or?
Assuming you have everything to make lights off work happy, it would work. But you could do it, but it would require a lot of setup.
Okay.
I don't know if they use any proprietary commands, but proprietary commands can be added to the IPMI simulator if necessary. Assuming they'll give you the information to write them. Anything else?
I think if you show this to the people who do the bare metal open stack stuff, they would love you. Because they could use it to do, I guess, some kind of testing.
Cool. Wouldn't they go through libvirt or something like that? Wouldn't that be
there is bare metal.
There is this ironic project which can really benefit with this because we are struggling to even test it. Availability of hardware is not always possible. We can simulate it with this simulator.
there you go. Yeah, simulation's a great deal for testing.
Those two guys, because they have to stuff in AI to test. So you said that you can even add the IPMI raw commands as well as the proprietary commands.
Yeah, you can. OpenIPMI is open source. It's extensible. Or the LAN simulator is extensible. It's all open source and extensible, but the LAN simulator part is the part that does this thing.
If I remember correctly, this article from Amador about fencing the nested VM, he needed to fetch QEMU to allow this IPMI operation like power on, power off. So
Right. The patches are. I'm working on getting them in.
Is there a plan to get it into
Yeah.
QEMU?
Yeah, I think the basic patches are pretty much accepted. There's patches dealing with ACPI to do the system tables, so that you can be auto-discovered, and SMBIOS, and those have some issues that need to be worked through.
And the other question, when the patches are in, so when we send power off to the VM, will it be safe from preventing us from data corruption of the VM?
It's just like a normal system. If you force the power off, and it powers off, it powers off.
Because the real fencing device, this IPMI fencing device signal to operating system to properly shut down. So
Right. You saw that the normal power offs does an ACPI operation and gracefully powers it down.
it would be much better because our work over then we are trying, to simulate fencing devices in nested virtualization for testing, and
Right.
from time to time when just kill the process with the data corruption for.
Right.
Once that in, it's really great benefit for us.
Right.
Okay, thanks.
Sure. Anything else? Okay.
From what I understand is with IPMI, you always need one BMC
Not exact. I mean, that's probably the best scenario. You could, I mean, it's all set up and it will work right now. You could have multiple BMCs or multiple management controllers, and each management controller could have a QEMU behind it. So you could have one BMC and then multiple other management controllers in the system, and have that you can talk through the BMC to those management controllers, and those can each have their own QEMU. So you could have one IPMI simulator and have an arbitrary, well, up to 127 or so QEMU implementations behind it if you wanted.
Have you thought about how to possibly integrate that with Libvirt?
No. I don't know a whole lot about Libvirt and how it interfaces with QEMU. I assume.
Well, it's the one that actually launches the QEMU process. So the question would be, would it need to launch a simulated process for each QEMU guest that it launches, or can it do that once when it starts up, and then somehow configure it dynamically to match the dynamically started guests and so on?
I mean, it should work as long as it has all the proper configuration to connect back to the simulator. So that over the char dev, it hooks back. It should just work.
When OpenAPMI starts QEMU, does it start it like as a daemon, or will you see what is there? Does IPMI care when the QEMU process exits?
It doesn't. Well, there's a little bit of monitoring. It'll work either way. So it'll start it, and if it has the PID, it can kill it that way. If IPMI has stage kill, so the first thing it does is a graceful kill. If nothing happens within a certain period of time, it goes one level up, and then it finally just sends a kill -9 to it. So if it has a PID, it'll do that. If not, it just uses the interface over the char dev to shut it down.
Or you put that as stop CMD?
That's already in there, actually. So that's actually part of the protocol right now.
But does that start command always need to be configured when you start up the simulator?
Yes.
Then it wouldn't work with Libvirt.
It wouldn't work with Libvirt?
But you can create those and modify those domains on the fly.
Yeah.
Modify those. You will just start.
So then Birch handles the configuration. You don't need to hard code. Just make start command first start and domain.
Yeah, you couldn't have like first start and rest of that.
Yeah. If anybody wants to work on Libvirt integration, that would be okay with me.
Like if you want to define the 127 MCs, do you have to do all of them, or can you just have a template and substitute a couple of things?
You would have to actually have all of them by hand right now. Yeah, you would. Yeah, so it would have to be configured by, and there's no reload right now in the simulator. So there's stuff that needs to be fixed to make it.
It's very simple to just have a single Unix socket.
Right.
Yeah.
Mm-hmm. Okay. Anything else?
Have you thought about implementing the DMC in QEMU, actually the processor, or some of them?
Oh, that's the internal simulator, yes.
Yeah, so basically it moves the simulator over to QEMU.
Yeah, but it doesn't have a network connection or anything like that. So it doesn't have that whole side of things. The code to do that is fairly large. I mean, you could put it in QEMU, but it'd be 20,000, 30,000 lines of code or more, and then it requires a lot of special networking stuff. It's nasty. The authentication algorithms and stuff are pretty nasty. It could be done, but I'd like to avoid it if possible.
But if the BMC from QEMU not even handle offline operating system comes up, you can start the QEMU process with -S so that it doesn't start out, and you can
Right.
use the no shutdown flag so that it doesn't actually exit when the guest shuts down. I've looked into actually implementing that, but then there were discussions whether that would actually be legal to implement it because of GPL and so on, and QEMU without signing legal agreements with Intel, and so I stopped.
Yeah. There's the whole legal side of things, but Intel has pretty much said it's okay with us. So the basic stance they have taken is any software implementation does not infringe upon their legal documents. So, so I'm okay with that.
I understand that you are an IPMI maintainer,
Mm-hmm.
but can you maybe still say a few words about Redfish?
Redfish? I'm not familiar with Redfish.
That's a specification by HP and some other vendors to actually replace IPMI, where IPMI was, a PvP-based networking protocol,
Mm-hmm.
and Redfish is a REST-based, HTTP-based thing, which is supposed to be more scalable for, I think, one server managing, like, a number of machines.
Oh, really? IPMI should be fairly scalable. I think OpenIPMI will support thousands of systems.
Well, you said 127.
No, that's an implementation that has to do with one IPMI simulator. How many QEMUs could you put behind that? That's the implementation of.
Simulator versus the protocol.
This is the protocol. So from talking from OpenIPMI to a bunch of systems, you could have many thousands. I would imagine that the better thing would be that since you're running HTTP, you can do HTTPS. You have better security. That would be the bigger deal for that, I would think, and that would be a good thing, I think.
But then you're implying that you're not seeing IPMI go away so soon.
No, IPMI is not going away anytime soon. No, it's not.
So let's move to the other room for the group.
Yep. Oh, we're late. Thank you.